All right, so I'm going live now. Okay. So hi everybody. This is Daniel from Diffusion Architecture. Today we have a great guest, Angelos Chronis. He is the CEO and co-founder of infrared.city, as well as the co-director of the Master of AI in Architecture and the Built Environment at the Institute for Advanced Architecture in Catalonia in Barcelona. And he is also senior research engineer
at the Austrian Institute of Technology.
Yeah, at the Austrian Institute of Technology in Vienna. And he studied at the architecture at the University of Patras in architectural computation at the Bartlett, and has been a Marie-Curie Fellow at the Innochain Innovative Training Network. He has previously worked as an associate at Foster+Partners and has taught at the Bartlett, Bauhaus University, and the University of Venice, and TU Graz and other universities internationally. His work focuses on performative design, simulation, AI, and data-driven design and optimization, as well as interactive interfaces with AR and VR. And he has led the development of various design and integrated simulation systems, such as infrared.city, a groundbreaking AI-driven climate solution framework. So welcome, Angelos. And today we're going to hear you talk about AI and the environment and how it affects and impacts architecture. So the platform is yours, and we welcome you.
Thank you very much, Daniel. Thanks everyone for joining and for listening to this very interesting for me conversation. I'm gonna start with a little bit of like a tangential presentation of what I think is important for our AI development for architecture and the built environment, and then I'll talk a little bit about my background. As you said, I'm an architect. I've studied architecture. I've done very little in terms of like building buildings. I've done R&D. I've been most of my career focused on research and development in architecture. I've been at Foster's. I've been a founding member of the Applied Research and Development team there, and I've also studied and taught at UCL. I was also at IAC, and I'm still at IAC, where I'm now directing a new program, which I find very interesting. I also want to talk about, which is the Master in AI for Architecture and the Built Environment, a very new program focused directly on AI and entrepreneurship. And in the past 5 years, I've been in Austria. I've been leading a research lab called City Intelligence Lab, from which we developed infrared.city, which is now a spin-off. And now that's how I ended up being an entrepreneur. I wasn't expecting that, to be honest, in my career. And that's how infrared.city was developed. But now I'm going to start a little bit like, going back to why, to the why of all of this. My whole career, what I've been trying to do is help architects and planners to design more sustainable buildings, to build more sustainable and livable cities. And I think that's sort of like where I want to start. So I'm going to start the presentation now. Let's see if my screen is shared correctly. Let me know if you can see the screen.
Yes, we can see it.
Absolutely. Lovely. So I will start with this sort of like idea of like, where are we right now with climate change? We are in a pretty dire situation. We're on track to blast through all the records. The last few months consecutively have been the warmest on record. 2023 warmest year on record. $16 million it costs per hour, and it displaces more than 30 million people annually. We're really in trouble. And I come from Greece. I normally like use these stats from last summer in Greece. We lost 2% of our land in wildfires and 5% of our GDP in floods. So we do have like a problem. I would like to bring us back to that problem as we develop cities, and cities are the core of this problem. 75% of us will live in cities by 2050. We need to build 13,000 buildings per day by then. That's what Autodesk says, at least. And buildings are still the largest contributors to climate change, with more than 35, sometimes 40% greenhouse emissions. So cities, they occupy 2% of our land. They consume 80% of the world's energy. And I like this image because it focuses specifically on the buildings that are the problem. And I think most of you know the walkie-talkie in London, or if you've ever passed by London, you probably know this building, walkie-talkie, which was also called the scorchy-talkie, because it was scorching cars, very expensive cars in the city of London, and essentially had to be adapted to stop melting cars and people's property. And it wasn't the only time that this was done in the history of architecture. Vignoli did the same mistake in the Las Vegas hotel, Tara Hotel, where they were the sort of like people who were working in the hotel were calling this that the ray of death, the death ray that was passing by the pool area and was burning people, not only plastic cups, etc. So like, if we are in 2020 and 2024 now, and we can't, figure out that the building will burn people, we have a problem. And I want us to try to go back a little bit in time. And I love this. This is like 15 years, maybe more now, 20 years ago. It probably shows my age a bit. And this is generative components. Back when generative components were essentially that, we can call it the parent of Grasshopper, when it was essentially parametric architecture before we go into the spaghetti we have today. So we went from here to there, and we also went from here. And this is, I think, for me, a very, very interesting image from the past, where we have like a free-form surface connected directly to solar radiation calculation that was done in Ecotect. That was a cast of the Biswas GC to Ecotect link. And it took me like 2 weeks to try to connect the two together, and it wasn't even possible. And today you go to a good food for Rhino, and you get like simulations for all sorts of things. So we've gone a long way, but we still have a lot of way to go. And I think now, which we're talking about AI in architecture, it's not for me like relevant that much to mid-journey and visualization. It's more relevant to what we can do in terms of performance in architecture. So how do we understand essentially the impact that our design has on the climate? And this is essentially the idea, at least for my career, this has been the most important sort of like driver. How do we connect design to all the different climate aspects, whether it is like wind, solar radiation, thermal comfort, rain, or anything else? And that's how we came to discover infrared, because the problem we have with these sort of like with the simulations that they're not like really connected. Even if you go to this, tons of tools in Food for Rhino, you still have like, time, complexity, and expertise issues. And essentially, infrared.city, which is the startup, is essentially focusing on directly this problem, making climate simulations accessible. A typical example: if you want to do wind comfort, it takes 3 days. We can do the same simulation in less than a second. This is sort of like a very interesting image for me, because it was like one of the first we developed in the project. And on one hand, you see like essentially a solar radiation simulation that takes like maybe 30 minutes to 40 minutes. The other is an AI prediction that is done instantly. And what we've essentially been developing is this sort of like generative adversarial networks, GAN models that can predict simulation results. In this case, we've done since then a lot of work with other models as well. So, but essentially what you have to do is run thousands of simulations. We create workflows where we run thousands of simulations with which we train essentially a sort of neural network to predict the simulation results. But before I continue, I'd like to go back a little bit to the CIL, where all of this was born. The CIL is essentially the lab of the Austrian Institute of Technology, where I was in the past 5 years I was heading, and where we developed with Yosha. I think it was also with you 2 weeks ago, and we developed together a lot of these tools, as well as infrared.city. And I would like to talk a little bit about like how we use sort of like generative design and AI-driven design tools in the lab, and how this essentially gave birth to infrared. So the City Intelligence Lab is essentially a laboratory within a larger research institute that tries to bring together all the different expertise, all the different sort of like aspects: mobility, climate, transportation, and energy, or all the different sort of like aspects of design together. And the lab is essentially where it all kind of like is brought together through these interactive integrated tools. One of the things that we've developed, which a lot of people might know, is the Decoding Spaces Toolbox. This was led by Professor Reinhard Koenig, who was leading also the group. And it is essentially a toolbox that allows you to very quickly, with the help of generative design methods, kind of like design urban forms. So essentially you take a sort of like a plot, and you can generate street layouts, you can generate sort of like typologies, you can essentially generate very quickly hold master plans and play with urban form without really ever, manually designing anything. This is for me like a very interesting video that shows how you can sketch essentially urban form. This is done by Rayed Mohammed, who's now leading computational design team at sorry, I forgot the company. At Henry Larson, sorry. And essentially you can see how you can very quickly sketch forms, urban forms, like very quickly play with sort of like designs without ever, again, designing anything manually. And we went also into mobility and accessibility, putting a point in the city, figuring out what you can access. All of these tools are sort of like developed within Grasshopper, custom tools that are sort of like enabling performance-driven sort of analysis of the city, like quickly playing with transport networks, changing stations, adding, removing stations, etc. But of course, also looking at climate. In this case, for example, we're looking at rain and how it falls through the city, identifying problematic areas, basements that can be flooded, and essentially coming up with resilience. So that essentially is what led to infrared, like this idea of having these simulation tools that take a lot of time, and how we can sort of like speed them up. And that's essentially what we did with infrared. We take something like, as I said, a wind comfort simulation, that it's a very sort of a complicated process that starts from designing, supporting a mesh, running a simulation, bringing back results, to essentially going directly from the design to the result. And that is essentially what we developed. So again, back to this image, and how do you develop essentially such a tool? You take cities like Vienna, you generate 3D models, you run thousands of simulations, and you train these sort of like adversarial networks to predict the simulation results. So there's a lot of like such examples out there today, but we were like one of the first to really use AI for this simulation prediction modeling. I'm gonna go directly into show you a little bit like how infrared looks like on the different sort of like modes. Currently, we have you can access it through the cloud, you can access it through a plugin, you can access it through the web API, or any sort of like a combination of those. So this is essentially a mashup of all the different methods. This is infrared in Grasshopper, so you can literally like take a building, move it around, and immediately get a simulation result. And of course, that allows you to generate massive solutions, massive sort of like design, let's say iteration. This is the cloud app. You can go to a specific location, for example, in Vienna International Center, where you can get like some data from OpenStreetMaps, very quickly select your area, select your site, and then I want to show essentially here how you can very quickly generate results, simulation results for wind comfort, solar radiation, etc. For a tower, for example, in just a click of a button. And again, going back to AI, I know most people are used to seeing sort of like generative imaging of sort of like dreamy landscapes, but like having a wind comfort analysis in a second is something that we've been trying to do for a very long time in this field, and allows you to really understand how your building impacts the environment, which is essentially something that will happen. That this building will be built, and then essentially it will have an effect on everybody's sort of like environment. The Grasshopper plugin, looking at parks in this case, you can move this park around using this generative design sort of like capability, where you just place a point and park is generated. You can move a sort of street layout, and masses are generated using decoding spaces in this case. And what you see here again is like immediately having wind comfort results accessible to you, again through AI. And this sort of like immediacy is again something that was not possible before. I've never seen this before in my career. I've worked 15 years now, and CFD was trying to do this for a very long time. So I was really glad to see it. You can also, of course, like change buildings, like add buildings, etc., and immediately see results. So that's essentially the power of infrared. And I don't want to spend too much time on it. We've also used infrared through Speckle within Revit. So I'm going to skip through this, which is also showing the power of Speckle and like sort of like integration of data. I don't know if you've ever spoken to Dimitri Stefanescu, another sort of like a good friend that has done a lot for this industry's interoperability of data. So here is like designing something in Revit and very quickly like moving it to infrared through Speckle and getting a simulation result. I'm going to skip through that because we don't have that much time. And finally, we have an API, which means that people like other people like Giraffe, for example, in this case, can take our simulation and directly integrate it within their own tools. And that essentially, allows us to open up the simulation as a service to everybody who wants to integrate simulation results. I'm gonna show very quickly, because I know we're very short on time, like how does it, what does this all mean for like really designing a project? In this case, this is a collaboration we did with Link Architecture, a Norwegian architecture firm, and we're looking at a master plan in sort of like waterfront redevelopment, where you can use essentially the sort of like quick massing from design, from decoding spaces, which I was talking about before, moving density in and out of that massing. And every time you do that, you're generating a solution that also generates sort of like performance maps, solar radiation, sunlight hours, daylight, accessibility, etc., all with the power of AI. And this is again where this sort of like idea of moving the park around comes from. But every time you move the park around, you're also changing the accessibility of that park. So you're connected to also figuring out how quickly people can get to that park, and how many parks are available to every sort of like citizen in this new development, or things like mobility, like transport stations, etc. Sorry, this video was not playing. I'm not sure why. And then even looking at things like noise. And I think I'm going to have to restart my presentation. Give me a second, because something has happened here, which is weird. Okay, share screen. Let me know if you can see that again.
Yeah, you're good.
Okay, so like noise, and I was like looking at mobility before, so essentially like moving transport stations. The idea of having like an integrated design approach where every time you make a decision, you're actually able to see the effect of that decision in every other sort of like aspect. And I'm going to stop here for a second and show what I think is the power of AI-driven design, generative design in the future. And I really like this video we did together with Yosa and others in the City Intelligence Lab, where we're using infrared. We're using the power of AI-driven simulation, but at the same time, we're using things like reinforcement learning or other AI models to very quickly find the optimal solutions for a specific sort of like quarter. It is an urban design project, but you have like certain objectives, thermal, wind, footfall, and accessibility, and you run thousands of simulations and thousands of designs together, and then you're able to very quickly figure out which ones are the best. But even when you do that, you want to continue with the manual design and sort of like bring that design back to the table, the sort of like negotiation table, and start playing with the design. And here's where AI is coming into play. We talked about sort of like I have a bit of background playing with AR, VR, applications, and I think this is one where it is actually interesting to use AR, where you bring back the design. You say, but I actually, in this area, I need also a tower. What happens if I bring that tower in? And then you send that design back to the kind of like machine learning, reinforcement learning, in this case, process, and it can find the optimal location for that extra tower. This play between the human and the AI is where I think the future of AI driven design is. It's more about sort of like AI bringing you a design and you trying to replicate essentially the dream. It's more about you negotiating, you having this idea of like the AI support in every design decision. And talking about design space exploration, talking about there's 1,000 possible iterations for any specific design. How do you really go about playing them? We had design explorers, we had sort of like other tools like that in the past, but now the idea, and this is I think what also Joshua is working a lot on, to go from the complex to the simple, to go from sort of like generating thousands and thousands of designs to actually being able to negotiate these designs. I'm going to skip through this part because we don't have much time, but like one of the things we've done a lot in the CIL is to really create interactive intuitive interfaces to allow the designer to really play with data, to select certain things within a in this case an SOM map, or like interactively looking at areas where CFD wind is sort of like performing more or better, and then play with this data and come up with decisions. And finally, I want to talk, which we talked about this before. This is essentially my favorite project. I want to talk about Brick Tree Hopper, which is a potential future of AI-driven and augmented reality sort of like design tool. where you got essentially a participatory planning tool. This is Average Joe. It's actually on our colleagues. And the city of Vienna has a mandate to plant 25,000 trees in the next 3 years or so in the city. And then Average Joe, our sort of like user here, goes on to Tree Hopper and decides where he wants to plant those trees in the city. And every time he adds a tree, he essentially sees the effect that tree has on the street where he's planting those trees. So it's not just like, where I want the tree to be. I want it to be next to my car so it's shaded. It's also like understanding at every iteration, like what that tree has as an effect on the climate. And then you go like in situ with a tablet or with a phone. And this is where I believe the future of design will be potentially. You can actually plant that tree, see it in front of you, see how it looks like, and at the same time feel or understand a little bit like the metrics, how much it sort of like makes the situation there better. And of course, the city can also look at these designs, figure out which ones are the best, and essentially come up with solutions. So I'm going to stop there. I'm going to stop there because I want to have a discussion with you. I would say the last thing I would probably want to say is what we're doing in IUAV with the new masters is focusing on all these sort of like exactly these topics and to bring a sort of like new idea to architecture education, where we bring the industry, we ask the industry to bring us the challenges that they're actually looking for, and when we bring these challenges to the students, ask the students to come up with solutions, and then the students get sort of like a hands-on experience by going into an internship with these industrial partners, and then hopefully, finally, in the second year, being able to develop their own ideas as a startup and being funded and continue further on. Because in a nutshell, perhaps the whole sort of like presentation is a bit confusing, but what I want to say is we need to change the way we see ourselves as architects, as planners, as designers, and escape the sort of like, cat monkey model, if I may say, where we go to this big firm, big name architecture firm, and essentially work for one mind solution. We need to go to a different sort of like mindset where we all together collectively come up with new solutions, new business ideas, new sort of like strategies for how to build more sustainable cities, because it will not come from sort of like some genius mastermind. I've spent enough of my career working with them. I don't think they are the solution. And I'm up to questions. I didn't want to spend too much time with the videos. Looking forward to the discussion.
Awesome. Thank you, Angelos, for that. That was a great presentation. And you really are working on a lot of diverse things that I think are very interesting, in how you are combining essentially like all these technologies in a way that can display like information about the environment, or just see how you can impact in a fast way. And I think the use of AI to speed up that process, essentially, of like the simulation process, has become like very useful. And with your company Infrared, I think that's one of the great potentials of like being able to simulate things as fast as possible. And that way it allows this interactivity between like the designer and the AI, essentially. Makes, I think, for like easier use of technology in the case where you have like stakeholders that can like visualize it also fast, and then you can do these kind of like fast presentations as well. So I think that's fascinating. But let's talk a little bit about your background, essentially, because you did study as an architect, but now you're more in the developer, or like, let's say, software aspect of things. So you went to school at Bartlett, also in Greece. What did you study there? Like, or how did you get interested in technologies? Were you always interested in technologies? And how did you get started?
Absolutely. I normally say I'm a failed architect. I didn't really manage to do architecture school like very, very well. I very quickly discovered I was studying in Patras. Patras, School of Architecture is a very traditional Greek school of architecture, sort of like typical modernism stuff. And I was really, really lucky to discover there a professor who actually changed my whole career, Professor Catherine Liapi, and she actually showed me the world of let's say design research, digital design. Back then we're talking about 2005, 2006, so like a bit early in that sense. So I started started very quickly playing with code. I remember I was like coding in generative components back in 2008, and it wasn't like really very, very common back then. And very quickly I realized I love programming more than, just playing with CAD tools. And that's how I ended up at the Bartlett at the AAC, at the Adaptive Architecture and Computation. Back then, it was a course that was actually really forward-thinking and pushed us to sort of like processing. Back then, I actually started working with processing. I did a lot of coding for the sort of like for Foster's. When I was at Foster's, I did develop a lot of new things. Built a whole lab eventually at some point, and the whole sort of like interface for design. We were calling it back then integrated modeling environment or something like that. And we actually essentially played with these sort of like ideas of, using processing back then. We did develop a lot of like interactive tables, interactive sort of like screens, and playing with form and seeing essentially the performance. It was always, for me, always related to essentially performance-driven design. My whole career, I've been focused on that. But then I left London because I was a little bit fed up, to be honest, also with the corporate environment there. And I went to the IUAV, where I actually, my sort of like context of applying programming and computational design methods opened up quite a lot, because IUAV is a great school. It has a very diverse set of things, from like physical computing, playing with the smart cities and toolkits, to 3D printing with clay and graphene. I remember we were doing sort of like let's say gradually differentiated materials like graphene with clay and concrete blocks, and we were like using also computational tools to figure out essentially the performance of these. And I think what for me made a lot more sense than the typical architecture sort of like a direction was the ability to bring the scientific sort of like aspect to it, the sort of like the more pure research aspect to architecture, essentially being able to argue with sort of like more concrete, let's say, points of why a certain architecture would be better than a certain other architecture, because it would perform better, it would be better for the people, better for the environment, than sort of like just I just find it cooler or something like that. So I think that's what drove me there.
Yeah, and that's like an interesting approach, because that would make it data driven, right? Or like that's kind of like one of your themes where you're able to quantify some sort of I guess like comfort or some sort of metrics within the environment, right? And then obviously with the ability of AI to be able to process this data, or this numeric data, then you can sort of figure out ways to optimize those aspects. So now you're at IUAV, and then IUAV is also like exploring kind of like this sort of innovative approaches into like computational design and AI. Maybe talk a little bit about the master's programs that you're working there, and how you see, I guess, like the process of teaching students about computational design and these technologies and experimentation with these technologies that can sort of impact how we do architecture.
Absolutely. So if I'm very honest, the reason I still teach, because I'm like, to be honest, my calendar, as we've figured out in the past few weeks, is a little bit like overwhelmed. The reason I teach is because I can't find anything more like exciting in my career, in my life, than getting to see younger professionals and students bringing their like fresh ideas. So I do believe that like people like I've been teaching and developing AI models and AI driven sort of like methods for architecture for like at least 15 years now. And I think that I don't have enough freshness in the way I'm thinking about things. So it's really, really empowering to see younger minds like, bring and attacking these concepts. But at the same time, bringing my expertise, what I can do is look at sort of like an idea and be able to shape it in a way like, technically how it could develop fast, what sort of like pointers I can give to a student. And together with Joshua, Stasia, David and everybody else in IUAV where we're teaching, I believe we can really sort of like empower these students to essentially have their ideas flourishing. But I do think that the reason I'm teaching is actually, I'm learning more than I teach. And specifically about the new master's. So the master's is called Masters in AI for Architecture and the Built Environment. it's a very new master. We're starting in September. I think what we're trying to do is really, really innovative. I wouldn't be part of this masters. I'm co-directing it with RIT. I wouldn't be part of this masters if I didn't believe that it can actually change a lot how people come out of it. It's a 1 or 2 years masters, but in most cases, what it does is it connects new sort of like AI models and methods, is sort of like really booming potential with actual challenges of the industry, bringing in industrial partners that essentially tell us, these are the 10 things we are looking to do in the next 2 years. And then through the internship program, through the entrepreneurship program, there's also the business school, EADA, which is connected with one of the best business schools in Barcelona, getting the students to understand how they can really take their ideas, the new things that they're developing and applying them in the industry, and actually, having a business perspective of that, like understanding the value. And I think what actually led me to try to influence also the masters to go that direction is my own perspective from the other masters, because I've been teaching also at MAK, I was also teaching at MACT and MAA, and we were like doing a lot of, pretty much most of the seminars and the studios of AI in IAC, we were doing together with Gyocho, together with Stasia and others. And what we've very often understood is, students come to these courses, they have zero programming background, they have zero knowledge of sort of like any AI, and within 3 months they get out studio project that you look at them and you're like, I can sell this tomorrow. Like I could definitely take this idea, go to a city, and the city would fund it with hundreds of thousands of euros to dollars, whatever, like to be able to develop as a large, like, scale up as a much larger idea. And I was always wondering, why are we as architects ending up after these really incredible sort of like, educational programs, working for pennies, if I may say, because the architectural environment, we all know, is not very well paid, right? To go to a big firm, get some stamp from some star architect's name on our CV, and then look for other jobs that will eventually end up, because I have all my friends, my network, they're like there for 10, 15 years. It doesn't get much better. So we could have architects sort of like, innovators, a lot more than we have today. Actually, McKinsey says architecture, engineering, construction is the second least innovative industry in the world after hunting. And essentially, I think that says a lot about us, and especially given how, impactful our sort of like field is. So my perspective with this new masters is, let's get the students of these masters to understand the value of what they're developing. Because every time I see these projects at every end of year sort of shows or reviews, I look at them and I'm like, you need to take this further. You need to continue this. You need to, you need someone to give you the seed funding or whatever you need to go for like 3 or 4 months, sit down, work with it, and then actually develop something. And I think that's exactly what we will do. We're connected with an accelerator program as well. So we actually want to get the students to build things, then go and develop them further. Also, some of the stuff that we did in MACAD with my sort of AI studio, a lot of these times we actually presented to the city of Vienna some of these tools. I am also always trying to bring sort of like jury reviewers that are not really the typical architecture school professionals, but like people who could actually get these projects and bring them forward. So yeah, that's essentially my, it sounds a little bit like a crusade, but like it's just what I believe would be the next step.
Yeah, no, and I think that's awesome. Like the idea of being able to empower architects or designers to take their ideas to this kind of level, but it can actually become a product. And I think what makes architecture or the study of architecture in school really interesting is that architecture comprises of so many different disciplines as well, right? There's like so many things that impact the built environment that as an architect you have to be aware of. And if you're able to connect these disciplines or provide some sort of way to do something more efficient, which I think that's kind of like the basis of infrared, right? Like climate is like a very important aspect of the world right now. You can develop a product essentially that somebody else would find useful, or a city, or like some other person or a business.
Absolutely.
So I think that's fascinating. Yeah, go ahead.
No, I think what you're saying is exactly the point. Like you, in this stage, we're seeing, especially with the AI sort of like revolution, we're seeing a lot of products, a lot of like startups coming out. Like infrared.city is just one of them. A lot of startups coming up with ideas of that could revolutionize how design is done in the future. I do believe that we will soon escape CAD. We will soon not need CAD. I've seen things from essentially. Sort of like ML driven ways to correct CAD drawings up to sort of like really complex MEP solving with ML and AI visualizations. You've seen that a lot. Like you can pretty much consider any visualization business. If you were doing renderings and you had like a team that was doing renderings, you need another job today because it's really not going to work, right? But it's not just about like how many jobs we will lose. It's the empowering of what we can do. Like this idea of escaping CAD. Think about it. Like 30 years ago, if you told people that you'll not have to draw things by hand, you'll be able to very quickly explore things and see them in 3D, they would be like, this is not architecture. This is, if I don't do a model, that doesn't make any sense. There is pretty much nobody that is like doing really large scale projects today that doesn't use digital design. The AI driven design era will come, will change everything we know about architecture. And essentially, as you do and as others, like, as I see a lot of like younger students like going into that direction, you're actually, you're shaping that new work. Like, that's why I think we also have some responsibility to make sure that we shape it to the direction of more sustainable architecture and not just, aesthetics is absolutely important. Architecture is all about aesthetics. So going back to your point about the multidisciplinarity of architecture, like being able to understand, you cannot be both a sort of like a water drainage expert, a sort of like wind expert, and a materials expert, vegetation expert, or whatever. But you do have, as an architect, to decide where all of these things will go. So these AI assistants that I'm talking about, where they essentially bringing you that information, and every time you change something in your design, they tell you how it performs, is exactly what we're doing in infrared.city, but also exactly what we teach in IAC in the new masters, but also the other masters. That's essentially, at least from my perspective, what I'm trying to do is exactly that.
Yeah. And Angelo, so something that you brought up is kind of like multidisciplinarity, but also having these AI agents, right? And we see like that's kind of like at least in the overall trend of AI from like large AI companies, they have this idea of like the agents, right? Or that's kind of like what their work in stores. How do we develop agents that can take tasks from humans, and then you can just assign them tasks and they'll carry out the task and do self-correcting or whatever. Now, what is interesting about this aspect is the idea of compressing sort of like a knowledge base, right? Somehow, where you can have an agent that compresses a knowledge base. In some sense, I guess infrared does that. It compresses some sort of knowledge base for climate simulation. Do you think this is kind of like where we're going, essentially, like where we're going to have this compression of knowledge, and then various disciplines or very tasks within certain disciplines are going to get compressed, where you can just hand it off to like an AI agent, essentially?
Absolutely. I think this idea of so that's why when I teach sort of like students, that we start with AI, and there's of course like the unsupervised learning, making sense of data without any clue, just looking at data, understanding patterns. Unsupervised learning is all about sort of like letting the data organize itself so that you can then understand the data. Supervised learning is like, I want you to learn certain things, and I want you to, I have a process. Essentially, it's like, in conceptually, a supervised learning, like the machine learning idea of like, the neural network is, trying to copy how we see. Like it's a computer vision sort of like more process where you say, here's a bunch of like, pixels or, inputs, learn essentially the connection between these sort of, data, this data, and this data. This is a very simplified, perhaps, approach, but you see my point. But the reinforcement learning is this idea of like getting an agent into the sort of like out in an environment and letting the agent perform something in the most optimal way, and like really getting the task done and learning how to come to new environments and completely sort of like unknown environments, and being able to find the way of getting this. I do believe that reinforcement learning will be in the future significant sort of like, this agent-based idea will be the significant sort of like leap. But every time we start with a new master's, with a new sort of like studio, I always tell the students who try to do reinforcement learning, don't do it. It's too early. We don't know yet enough. We don't have enough models. They always struggle. We always have at least one group that's struggling with reinforcement learning. But yes, this idea of the agent, having your idea about like the compression of the knowledge and knowledge base is excellent, and very sort of like, it's exactly what we're talking about. I'll give you an example from like real like a live project. When I was at Foster, I worked in about 50 projects, including Apple's campus and sort of like Beijing airport, not Beijing airport, like New Mexico airport, etc. So like really big projects. One of the ideas that we started early on was like this idea of integrated design. So you would bring the head of the environmental engineering group, the head of sort of like structural engineering group, the head of the ARD group, and I was like essentially in many cases involved in that, because we were like, the ARD was a small group, and we would always, I was doing most of the sort of like technical work, so I would go into these meetings, and it was amazing because you have like a meeting in the beginning of a project, and you say, what can we do? And you would immediately have the environmental engineer, the sort of like, structural engineer telling you, "No, but this won't work. The spans are too big." The environmental engineer would tell you like, the mass is too big. Like energy won't work, temperature, etc. And like you could get these answers immediately, but you couldn't have them in every meeting because they're like busy people. So getting their brains down to on a sort of like AI model, and having this virtual sort of like discussion with all the different sort of like engineering groups, having this integrated discussion without actually having the people there, is everything you're talking about. It's like this idea of having an expert without having the expert there. And we will see a lot of like IP conflicts, a lot of like intellectual property issues there, like who owns what. So like if you check all my papers and then you start advising people with my papers, do I still own that property? It's going to get a little bit complicated, but that's essentially where we're going. Like in your idea of the agents being able to negotiate designs, being able to tell you essentially if something works well or not, is exactly, talking about simulation. I'm doing wind simulations for like 15 or so, maybe more, a little bit more years. And if I look at the design, I don't have to run a simulation to know like roughly what will happen. I could tell you directly, this tall tower here will generate a wake here, and this area will be like having very high winds. Although wind is a little bit complicated, you could definitely do that with solar radiation and things like that. Someone would tell Vignoli that the scorched turkey will burn cars. Like someone should have done that, to be honest. But that's a different discussion. But running the simulation to get this, to learn that, is what we have today. You go to Ladybug, and thanks to Mustafa and his amazing work, we have this tool. But like still, you don't understand what that simulation means unless someone kind of like explains it. One of the things we're doing in infrared is exactly that. You don't need a simulation at some point. You need someone to just tell you that design won't work well. Of course, you need a simulation for fine tuning, but the level of detail, the level of resolution you need depends also on sort of like, the level at which you're looking at the problem. For example, when we're looking at daylight or sort of like visualization, right now you can do like a sketch in Photoshop and say, put some trees there. Yeah, of course, that won't be an accurate representation, but it's good enough for a rendering that you show to a client. Then you have to work out the tree layouts and all the things that will happen. But in the beginning, it's the same with simulation. It's the same with performance. You need to just get a rough idea of where the performance will be better.
Yeah, and I think one of the interesting parts about that is that then once you do this, you can start quantifying things, and I find that fascinating. And it's kind of like where we're all going, where you can't quantify data at this point, right? And recently, for example, and I'm just kind of like thinking about like big AI companies now, like in the case of Anthropic or OpenAI, where they have collected this vast amount of data from the internet, trained these large language models. They encode all this data, bring it into sort of like smaller compressed space, and then they can begin to map out patterns, and then it become, gets visualizations of how, I guess, thought patterns or structures in language, right? And I think that being able to see that also helps you see the world in a new way. Being able to see visually how climate or wind and things like that you're talking about, see it fast and speedy, or visualizing it in a new way using AI, also helps you like get more intuition for somebody that maybe hasn't had like 15 years of your experience seeing all these like simulations. And that would affect not only kind of like senior people, but also people that are coming in, like junior people, that then it can now take a look at this, possibly ask AI, like summarize the results of this simulation, and it gives you like a quick summary, kind of like when you take a test, feed it into ChatGPT, and it gives you like a summary of key points. Do you see that essentially that's kind of like what we should optimize for in developing these kind of like compressive knowledge softwares with AI?
Absolutely. And I'll take it a bit further because, like, currently we're talking about sort of like designing buildings, right? Like, and you say, imagine I'm a big developer. I'm going to do like, a big residential tower that I'm going to essentially create 1,000 apartments. Okay. Like, I'm just saying, just random numbers, like a big residential sort of like development, multiple towers. I'll do 1,000 apartments. And I currently will optimize it a bit, right? I would say, I want to have all of them have a good view, like, being sort of like, I'll look at my market and say, they have to be like 2-bedroom houses because that's all we can sell here, etc. Whatever. If I could look at these 1,000 apartments and I tell you that, 200 of them, the ones that are on the top 2 floors, the way you're building them with with the glass and everything, in 2050 will be almost uninhabitable because you'll have to have, your heat waves are going to be like 30 days long, and you'll either like break your air conditioning or you'll have to like find another way. Then people will start thinking seriously about, what am I doing here? And I think, this sounds like science fiction, but actually this is what happens right now in the States in insurance companies. The insurance companies are looking at essentially where wildfires will happen and where floods will happen, and they won't insure your house. If you are almost certain that your house will be either burnt or flooded at some point in the near future, why would they insure your house? So it will happen, and it will happen more and more. And I think we don't really understand where climate change is taking us, but it will have an impact. And designing without that in the mind is like it's a catastrophe. It won't work. So this knowledge will pass, of course, to everyone with digital tools, with AI tools, surely. But on top of that, what I think will do, it will happen also. It will pass also to the ones that are buying the houses, the ones that are like essentially like the owners of the properties, the owners of the house, and then in the end, you as a designer, you as an artist, you'll be very, very hesitant in developing something that the developer cannot sell anymore because the user will know. That's also what we're trying to do at Infrared. And talking about, the younger sort of like, students that come to these courses, what do they expect? I expect you, all of you, like you, I think collectively, in a collective sense, to reach a point where you will create tools on the fly almost. Like you will create sort of like a new tool every time you're designing a new project. Because currently you have Grasshopper, you have like what I find really horrible spaghetti business of I have to connect things with each other. But imagine a Grasshopper that works with prompts. Essentially, you say what I care about in this sort of like environment. I care about a house that's protected from the sun from the south, and then that's also sort of like gets as much as sun as possible in the winter. But also there is a forest next to it. I want to have a protective buffer to it. And by the way, this sort of like river is over here, and if it floods, I want to have essentially a sort of like inclination that would allow the walls, whatever. You can specify these 10 things, and then imagine that a bunch of tools popping up. That would be a flood simulation, a sort of like wildfire simulation. Again, one of the things we're trying to build with Infrared is this idea of like being able to connect things very easily together through multimodal or other sort of like approaches. And eventually, imagine like not having Grasshopper, but having sort of like other computational design tools that allows you to very quickly connect performance, visualization, energy, or other sort of like things with design and intuition, design interaction. That's exactly what like this video, this sort of like idea of reinforcement learning was about. You hold as an architect domain knowledge of architecture. You need to be able to negotiate these things, but in the future you won't need the sort of like computational design, like you won't need this sort of like computer science knowledge to develop these prototypes. You'd be able to develop them on the fly as you do today, apps on the internet without any web, HTML or JavaScript knowledge, right? So imagine being the architect software developer in one, where you very quickly come up with design systems. Ranko Kolarevic, which I admire a lot for his writings, said like long time ago that there's a shift from designing the form to designing the system that designs the form, right? And then that was essentially the idea of morphogenetic programming, morphogenetic sort of like computational design back in the day. You're today designing the system that will design the optimized design for your optimized architecture for your set of objectives for your problems.
Yeah, no, that's really interesting. And I think let's talk a little bit about essentially where you see, I guess, like you are picking like specific data sets, because I guess when it comes down to this, you also need the data sets, right? Data set collecting is expensive, and it's part of the process of using AI, and being able to compress all this data into a useful product requires collecting high quality data sets. Talk a little bit about the importance of essentially what the data set that you need to collect is. Like, how do you get quality data, specifically for what you're working on? And do you see essentially any avenues or potential where I guess like incorporating different data sets from like various disciplines, and how they can be incorporated into this?
Absolutely. And I'm just like a little bit like randomly answering these questions, but like there's like when you're asking me, like there's a lot of things popping up in my mind. So I apologize. I apologize in advance for like how hectic this information may sound on the blog, on the post. But it's just like firing up. My neurons are probably firing a bit more than they should. But what you're saying about data, like I think there's a few things that I want to talk about. So first of all, these days I was having a discussion, a pre-panel discussion about we're having a panel at the AI for development countries, which is happening in the United Nations here in 2 weeks, and I'm part of it. And we were talking about data sovereignty, like law. It's about law mostly, and about how sort of like IP laws and AI laws can help the development of those. And I was telling these guys essentially that if I look at what Vienna is like one of the best cities in the world for open data. They have like an open data repository. It has like everything from where benches are to where like every lamppost of the city is, to where the bins even are. So you can get everything. You get open city, open access, or like Melbourne also amazing sort of like data sets. And I was saying like these data sets that these cities have, which are like really, really data rich, they have no clue about the cities in comparison to how much Google Maps knows about those cities. So we're talking about data, and we're like, always preoccupied. There's a lot of data out there that can actually allow us to do a lot of things. And I'll give you like a few examples of like the student projects that we've done in AI, in IAC, on the AI masters, on the AI seminars. And you'll see like, what I mean, like Vienna, looking at street view images, like just street view images, and being able to understand at every cycle path how the pavement or the vegetation or essentially the safety with other cars proximity is. So instead of like just cycling through the city, through whatever like the city says is this sort of like cycle paths, being able to weight these cycle paths and say, I want to travel from point A to B, but I want to go only through paved roads and not through cobblestone, because cobblestone is horrible to cycle on. I want to go from point A to B, but always be in the shadow. So I want to have vegetation around me. And you can just look at street view images and be able to map the whole city like that. Other examples, looking at thermal comfort, right? And like just looking at how much sky you can see and how much, materials you can see around you, how much reflectivity, etc., along the path. Just looking at the street view images, you can understand very accurately, essentially, the sort of like the percentage of like sky access you have, or how hot or how cold that street will be, that point in the street will be during a heat wave. And you start getting into sort of like this idea, like even looking at simple things, proximity of a street to is a police station, or proximity to the street of the street to sort of like, or integration of the street, like space syntax metrics, and connecting it to safety and other. These are all projects that I'm talking about. So you have enough data to understand way more things about the city that you actually do if you look at just the city, sort of like what every municipality has, and that's where I think that eventually, what we will do is, as architecture and planning is also looking at the BIM data that we have, all the sort of like performance data we have for buildings, is that there will be a point where, there will be a massive explosion of, again, tools, startups, products, whatever you call them, that will be able to tap on this existing data and give you like way more information than you can now imagine. So I don't think that the problem is data. I think the problem is how much we are tapping on this data.
Mhm.
And for sure, infrared, what we're doing is we're developing our own data sets. We're creating our own data sets. That's one of the the best things we own is essentially all the data set simulation data sets that we can use, and also the expertise to produce them. But eventually, I can see a world where like everybody's tapping on our, for example, simulation data and like producing better, so like simulation tools that we can integrate infrared as well. We want to be very open about this, or producing sort of interfaces to this data. So, in a nutshell, what I think we have today is an incredible ability to understand things about our cities and our buildings, but we haven't even touched on that data yet. That's why one of the things we do in the masters, the first thing we do is actually get students to really understand how to structure and acquire data from open data sources as well. You don't have to be Google. Again, example, Google Places this API. You just use it to just download reviews of squares, of public squares, or reviews of cafes and restaurants, and you can make a map of how diverse a part of a city is in relation to like different social groups, whether it's like LGBTQ friendly or whether it's sort of like a certain nationality or certain like ethnic group friendly, etc., etc. Like you can actually look at just reviews on Google Maps, and you can understand things like that. So, or like how open a square is or how comfortable a square is. We also do, these are two projects again that come to my mind from my. I'm sorry if I ranting a bit too long for, yeah.
No, no, I think it's super interesting because it is available there, right? Like there is data, and I think like what's also interesting about having city data, and I think it was NVIDIA, and there's like a few kind of like companies that are sort of building, let's say like a digital twin of Earth, right? And trying to map essentially all these natural forces and things within planet Earth. Which at some point, I guess it depends on like the level of resolution that we get that we can actually apply now AI or any sort of I guess way to manipulate the data or get some insight from it. Maybe let's move now because we're coming up to the hour. But how do you see the AI transforming, I guess, the field of architecture and the built environment in the next decade? We talked a little bit about that, but based on like where you are focusing with your company, how do you see maybe some efficiencies, or do you see kind of like radical changes in how we do architecture in the built environment?
Absolutely. I think that Mid-Journey essentially brought the attention of the architecture to AI. It's true, right? It's very true. Like suddenly everybody was able to generate a dreamy image of any architecture they could think of. Very quickly, people understood that they could do renderings, through that route, with not really needing a rendering company anymore. But what really brought, architects to Mid-Journey was not the model itself, right? It wasn't really, the model existed quite a bit before architects could reach it through Discord. It was Discord that brought, a bunch of architects to Mid-Journey, because you could just write something on Discord. You didn't have to download anything. You didn't have to, install any libraries. You didn't have to solve any sort of like Python environment problems. You just went on Discord, type a command, and like, and why I'm saying this is because I think that integration is pretty much everything in relation to how we bring AI models. We as architects, we bring like, we take the AI models that are like out there, and we, as we do always with technology, we appropriate technology a little bit later. So we take the things that are already out there and we bring them, because we also don't have, the essentially the value added essentially to pay for like, having the most cutting edge models. Why do we have, Google building, let's say, Sora or whatever for, video makers, and not building, let's say, a CAD BIM essentially generative AI model, right? Because although we are a much larger industry, we are not connected. We're not gonna, they're not gonna get like, 9 billion architects to play with this. So what I think will happen is we will see radical changes, radical in the sense of like the whole business model of architecture will change, and we will end up with a sort of like a very different, perspective of how good architecture can be done, where you will be able to integrate sort of like software AI tools very quickly, but you will also be able to sell sort of like products in architecture much easier. So essentially, you as a designer, you're not selling your, let's say, signature design only. That's not like, I think we're going to deviate from that. And what you're selling is essentially, your the way you're designing your workflows, your suite of tools will be able to deliver value that now also is looked at in a more sort of like let's say precise way. So I'll give you the example of China, which was like building most of the buildings that were being built for like a few years. Now it's slowed down, but it will eventually continue. Very quickly understood that weird buildings, as they were calling them, were not like essentially the future of architecture. They were looking at efficiency. They were looking at how can I maximize performance. Sustainability will definitely be with all the ESGs and the taxonomies, all of the things that are coming, we will have to change the way we are designing. So I think what will happen is eventually you will be seeing essentially, like WeWork was a great example of that. Or like you would see corporations or like agglomerations of design and development and value, like let's say real estate companies bringing together products, in the sense architectural products that will be based on performance, on efficiency, on sort of like delivering value. Like, what do you normally see in these AI tools these days? You say, I can generate a design for you in, let's say, an hour. Instead of you having 20 architects creating designs for you, I can generate one design for you. And still, we're not there, right? We cannot really design like that, but we'll get there. If you combine that with, I'm going to generate performance for you in very, very quickly. If I'm going to generate like how much the value of your architecture very quickly. If I can generate how quickly you can reach the closest metro from anywhere you design a building, et cetera, et cetera. Like if you combine all of these things, which is essentially what we were trying to do at CAL, you essentially end up with, I say we work for a reason, this sort of data-driven design optimization where you get, an office space which is optimized. Every card tap, every move of a chair was actually recorded at WeWork, and every floor plan was optimized for working, working out the best sort of like value of that floor plan. Everywhere WeWork was being built, was being sort of like developed. You would have studies going on onto like how quickly you can get to any sort of like building around you, et cetera, et cetera. So like it was a very data-driven process. It went down a bit for other reasons, but this idea of going into sort of like a very data-driven, optimized way of designing will be eventually everywhere. And I think studying AI today, I mean, if I was a student, I wouldn't do anything else. I would just go all in on AI.
Yeah.
So I know it sounds like really like annoying, but like it is for me that I'm like doing this for 50 years. It's I call myself an AI boomer. I find it very, everybody's doing AI, right? But at the same time, it's true. This is essentially what you have to do. That's why we're doing this masters, because I do think that there's a big impact coming.
Yeah, awesome. So and then like something that you brought up is kind of like the idea of integrating pretty much everything within a data-driven platform, and then everything's going to be resolved at various levels of resolution, and all the information is going to be easily accessible, right? And a large language model or whatever you have is going to be able to access that just by prompting, and then it can spit out the visualization. So that's I definitely do see that happening. Yeah, hopefully. Yeah. And then just finally, what do you see as essentially like the use of AR and VR technologies within the simulation? I think we're getting close to, the idea of having like the Vision Pros or something like that, and being able to see the environment within and simulating things. Do you find that is something that is going to become more useful?
Yeah. Now, there, you might hear me having a bit of a more pessimist view. I'll touch first. I'll try to do like a sort of like bridge. We were talking about this integrated view of everything, right? When Boeing, I think Boeing is a bad example. When Airbus is building a new plane, like every component, every screw, and then again, Boeing is probably not the good example right now because you've heard of what is going on. But every screw, every let's say material, every sort of like connection is part of one big model, and everything affects everything else. So you have to check everything together. So it's very different because you only build one plane, and then you're like selling it for like years, and each plane costs like millions and millions, billions of euros or whatever. But this idea of a really integrated design approach where every radiator is affecting the energy, and the energy of this room is affecting the overall energy of the building, and the overall energy of the building is affecting whether the green roof will work well or not. This idea of a connected model that then connects to the GIS and looks at the Landsat, temperature of the surface of the Earth at that point, and then projects it to 2050 and says, this roof, you need it's going to receive so much radiation that it will die. Therefore, your whole energy concept for the model will die. So therefore, you need that radiator to be a lot bigger than it is right now because whatever, like just giving you a very bad example, but you understand what I'm like. I'm saying everything is interconnected. And I think that with the explosion of AI tools, like being able to really quickly get the relationship and the patterns of relationships of data between all these different things at the same time as integration. That's why I think Spectral is a great example, because it goes into that direction of integrating data. I think that can completely change the way we design. Now, going to your AR VR question, can we see that? Can I actually go into an existing environment and see, like how my building will perform, how beautiful it is at the end of the day, because it definitely makes sense. How can I see from this view here that, the trees that will not affect, I can play around, I can have like an AR tool that I can play the whole year and like look at the different changes of seasons and see that, right? And, connecting that to perhaps like Omniverse or something like that, I could literally leave, a whole year of my apartment in a few seconds. And that would mean that if I go to a new apartment, I would actually ask for that. I would say, I want to see the view of that building. And then you would be like, okay, the sun is coming in and hitting my bed every day, for hours, and I'm going to get scorched or whatever. I don't like that. I want to go to another apartment. You would be able to have that. Would be amazing. I have been working with VR tools and AR tools since the very beginning of them, and I'm like saying that because I didn't even like it. It was just randomly happened because I was working at the ARD. Oculus, I worked with the first development kit, the Kickstarter one. The one was like essentially the crowd-funded one, and HoloLens I saw like maybe 6 months before it came out, when Microsoft was asking us for like $2 million to make a promo video for the use of HoloLens before it came out to the market. I would love to see, and I would love to say that we're going into the this. I've given a TEDx talk about like VR for education, and like how we could see a world where we can see through our eyes and be able to sort of like see augmented reality. But unfortunately, the technology has not progressed a single bit since 15 years ago, and we were all waiting for Magic Leap to come up with this sort of like retina projection technology that they were talking about. Nothing happened. But Magic Leap was a big failure. I do hope that something will come out and prove me wrong. I currently see only VR as sort of like or pass through VR. I have very little trust in the sort of like how is it called, like Magic Vision, Magic Vision Pro, like whatever. I have very little trust on it as a device, that it's actually now going down, and I think they stopped working on a second version. I would love to see a technology that will bring that to us, but up to now, every technology has kind of failed me, and I'm really sad. I would love to see this going forward, but I don't think we're still there. Hopefully soon. But I do believe that AR would be the fundamental, if someone solved the ability to, like, just put my glasses on
Yeah.
and see things on the world, that would actually change things. Any device that, makes me like feel like I'm like a cyborg won't work.
Yeah. And
Google
I
Glass,
think
I
that's,
also tried Google Glass when it was out.
yeah.
Terrible. Absolutely terrible.
Yeah, and I think that's kind of like Mark Zuckerberg's like current stance right now,
Yeah.
where they're really trying to get the Ray-Bans to be able to do that, but we'll see if it ends up working out or not.
They bought Oculus. They put so much money in it. I truly hope something will come out. Like, I don't trust if it comes out of Facebook, it will probably be connected to a really bad content world. I don't think that, that world, like, at least for me, right? Like, it's not my preferred
Yeah.
content world, but the technology, someone needs to solve the technology because we are not there.
Yeah. Yeah, all right. So Angelo, we're closing up on the hour. So any final words or thoughts? I guess you already said to people that they should, if they want to do AI, jump in straightforward. Do you have any final words or advice for young
Yeah,
architects or practitioners about AI in architecture in the built environment?
absolutely. First thing I'd say is just, this is a shameless plug, but I do think that, like, I want to help people. Like, if anybody wants to work with infrared or like play with infrared, shoot me an email. I'm pretty sure you can get the email like out there, or it's angelos.chronis@infrared.city. It's very easy. And essentially, everyone who wants to get into that master's program, because we're still having, like, scholarships out, like, also shoot an email. It's the same thing, angelos.chronis@iac.net. And what I want to say as a, as my sort of, if I can give any advice, it would be really, like, jump out of your comfort zone right now and get into, you know, playing with, AI technology, playing with sort of like all sorts of like innovation in architecture. This is the right time. I wouldn't say that perhaps like 10 years ago, maybe it was also sort of like into this uh, corporate world. But, I think that from my perspective, my own career, I think I should have gone out of, like, this corporate sort of like world faster than I did. You have very little to learn from the star architects. Get out of this mentality and go change, innovate, change the world of architecture. Today, now is the best time. Go educate yourself, whether you go to IAC or anywhere else. Build, products, build companies, build sort of like ideas. When I talk to, VCs, because I'm like now in this sort of like moment of, like, entrepreneurship. When I talk to VCs and other startup founders, other sort of like, in other fields, realize that we have. How I know so many people that could have, flourished, could have, like, created like products that would have exploded in our field, which now makes me understand that this is exactly why we are the second least innovative industry after hunting, because we just go and hunt as architects without actually thinking, yeah, we can change the way we work, we can change the way we deliver value, and we can change the way we understand our own value. You are responsible for the living conditions of everyone out there, so change the way the way this is done. That's it.
Awesome. All right.
The motivational speech number 27.
Yeah.
Thank you.
Okay, awesome. Angelos, thank you so much for this. Really exciting presentation and conversation. It's definitely eye-opening, and I think you kind of charted a few ways in which AI is going to be impacting the built environment. And congratulations to your company and your team working on a great solution, right? Making climate simulation as efficient as possible.
Thank you.
So for
Thank
that.
you. And congratulations to you for, like, really, like, for this the channel and for these initiatives, because you really, like, I think what you're doing is really exactly what we need. We need to talk more about this, and bringing these, colleagues here, and, like, allowing us to sort of give us our sort of like insights is really, really useful.
Awesome. Yeah, thank you again, and best of luck, and hopefully we talk soon again, Angelo.
Cheers. Cheers. See you
All right,
soon.
cheers.
Have a good one. Bye bye.